Hello everyone, welcome to this video on practice problems on quiz 2. So today I'm going to solve some important problems uh, for quiz 2. So let's begin. Here is my first example. For a normal distribution with mean equal to 266 and standard deviation 16, probability that x, or the random variable, lies between 230 and c is equal to 0.3416. Find the value of c. So clearly from the problem, what you know is this is the problem on normal distribution. So we are going to sketch the graph and then we'll try to represent the probability on the graph. So let's begin by drawing the normal distribution. So say, for example, this is my graph for the normal distribution with the mean of 266 and standard deviation 16. Along the x-axis, we have the random variable x, and in the middle, we have the mean, which is 266. 266. Now, the question says, probability that x is between 230, 266 is here, and then the standard deviation is 16. So if we go down by 16 couple of times, we'll be close to 230, which will be somewhere here. Okay, will be somewhere there. And that value is 230. 230. So now the probability that x is between 230 and c, I don't know where is c, but I can see that the area is like 34%. So maybe c is still on the left of 266. I don't know where it is. So what I'm going to do is I'm just going to write c somewhere here. What I know is from this inequality, at least I know that c is greater than 230. So this one will be a good representation. If we get c more than 266, then we know that c is somewhere here. Otherwise, if we get less than 266, this diagram will be perfectly fine. And then this area, because the probability is equal to area, this area between 230 and c, this area is given as 0.3416. That is the area given to us. Okay. Now we are asked to find the value of c. So if I want to find the value of c, what we know is for a normal distribution, we can easily use TI-84 calculator and we can find the value of c. But in order to find the value of c, we need total area to the left of c. We have this area which is on the left of c, but this area, I'm going to show you here in red, this area is missing. So first of all, we need to find this area in red. Okay, we have to find that area in red. So let's do that. So I'm going to do it in red itself. So area shown in red. Okay, red color. I can call that as A sub 1 if I want. This area is equal to, in order to find the area using TI-84 calculator, we can use normal CDF. Okay, normal CDF. The lower boundary for the area is negative infinity. Upper boundary for the area is 230. Mean is 266. And the standard deviation is 16. Now, we can type this in our calculator and find the value of that area, which is in red. So in order to do that in our calculator, we go to second, vars, and then number 2 for normal CDF, and we plug in the values. Infinity, we have a negative infinity, so write negative E99 in our calculator for that. Okay, upper boundary is 230, mean is 266, and its standard deviation is 16. And if we type all that information in our calculator, we'll get 0.0122. So this area in red is 0.0122. So once we have that information, we can find the total area that is to the left of C. So the total area that is on the left of C is this area in green plus the area in red. So I can write that total area, okay, total area to the left of C is equal to 0.3416 plus 0.0122, which is equal to, okay, 0.3416 plus 0.0122. So if we add these two, we get 0.3538. So with that, we got the total area to the left of C. The reason we want to find total area to the left of C is that will help us find the value of C, because we have this one for our calculator. C is equal to, C is the value along the x-axis. To find the value along the x-axis, we use inverse normal. So we can write inverse normal, and we need area to the left of C. Area to the left of C is 0.3538, 0.3538. Mean is 266, and standard deviation is 16. So if we type this information in our calculator, in order to type the information in our TI-84 calculator, we go to second, vars, and then number 3 for inverse normal. Then we'll we'll just enter the values, which is area is 0.3538, mean we have 266, and standard deviation is 16. We have the area on the left, and then we'll be able to get the value as 259.9858. That is the value of C. So C is equal to 259.9859. And my diagram is perfectly correct because I got the value of C, which is less than 266, which is on the left of that. So one more time, remember, if we have to find the value of C or something like this, which is along the x-axis, what you have to do is you have to find the total area to the left of C. Once you calculate the total area to the left of C, you can use inverse normal to determine the value that lies along the x-axis in the distribution given. Okay, that is our first example. Now let's move on to second example. Okay, here is my second example. Let's see what this question is about. The mean weight gained during pregnancy is 30 pounds with a standard deviation of 12.9 pounds. Weight gain during pregnancy is skewed right. A random sample of 35 low-income patients has their mean weight gain of 36.2 pounds. We have to find the mean and standard deviation for the sampling distribution of sample means, and we have to find the probability that the average weight gain during the pregnancy is more than 36.2 pounds. Okay, one information that's given here is the general information, which is given here. The mean weight gain during the pregnancy is 30 pounds with a standard deviation of 12.9 pounds. So that information is about the general population. So this is the information about the general population. So for the population, they have given that the mean of the population is 30 pounds and the standard deviation, okay, standard deviation of the population is 12.9. So you can clearly see that the mean and standard deviation is given. Okay, because the mean and standard deviation is given for the population, we'll be able to use the central limit theorem easily. They have one information given here: weight gain during the pregnancy is skewed right. But what we know is whether the data or population is skewed left or skewed right or normal. If the sample size is more than 30, here it is 35, the sampling distribution will be normal. So you can see a random sample of 35 low income. So 35 is the sample size, which is greater than 30. So here we have n greater than 30, which is 35 in this case. Okay. Have their mean, that is the sample mean. This is the sample mean. So mean weight gain is 36.2 pounds. So what we have to do is we have to find the mean and the standard deviation for the sampling distribution of sample mean. What we know is, since the population standard deviation is given and the sample size is greater than 30, what we know is by central limit theorem, the sampling distribution, okay, the sampling distribution of sample means is normal. It's normal. And for this normally distributed samples, the mean of the samples, which is mu sub x bar, will be equal to population mean mu, that is 30. And the standard deviation of the sample is equal to population standard deviation divided by square root of n. Population standard deviation is 12.9, and we divide by square root of the sample size, or square root of 35. And if you do that, we get 2.1805. You can check that using calculator. So we got the mean and the standard deviation for the sampling distribution of sample mean. And also we know from the central limit theorem that the sample distribution of sample mean is normal. So with that, we solve the first part, part A. In the second part, we have to find the probability that average weight. So you can clearly see we are talking about the average, okay? Average weight gain during the pregnancy is more than 36.2 pounds. So what we are going to do is, because we are looking at the average weight, the probability that the average weight gain is more than 36.2 pounds, we are going to draw the distribution for the average. And we already know that the sampling distribution of sample mean or sample average is normal. So we are going to draw that normal distribution. So let's sketch that graph. Okay, suppose that is my normal distribution. Remember, this is the normal distribution with the mean mu sub x bar and standard deviation sigma sub x bar, because we have x bar along the x-axis. And in the middle, we have the average of mu sub x bar, which is equal to 30. So 30 goes in the middle. And we have to find the probability that the average weight gain during pregnancy is more than 36.2. So we need to label 36.2 along the x-axis. We have 30 here in the middle, so 36.2 will be on the right. Okay, so we can have 36.2 somewhere there, 36.2, and we want the probability that the average weight gain is more than that. That means this will be equal to, that probability will be equal to this area. Okay, it will be equal to that area. So now we can easily find that. Now probability that average is greater than 36.2. Greater than 36.2 is equal to area. We can find area using normal CDF in our TI-84 calculator. And the lower boundary for the area is 36.2. Upper boundary is infinity. Mean we have 30. And then standard deviation we got here, which is 2.1805. So now you can type this information in your calculator, and if you type that information in your calculator, you should get 0.0022. That means probability that the average weight gain is more than 36.2 pounds will be 0.0022. That's a very small population here, because the average is around 30. So we are looking at 36.2, and standard deviation is very small there, 2.18. So this value, 36.2 or more, will be very small. That's why we get the probability that X bar, or the average weight gain, is more than 36.2 is 0.0022. Okay, so that is the problem based on the central limit theorem. So that is the second example. Let's get into third one here. So here we have the third example. And in this example, let's see what we are asked to find. A simple random sample of size 25 is drawn from a population that is normally distributed. Okay, unlike the previous example, in this one, the population is normally distributed. Okay, from a normally distributed population, a random sample of size 25 is drawn. So the sample size, as you can see, okay, sample size is 25, n equal to 25. The sample mean is found to be 108. So for that sample, the sample mean is 108. So X bar is 108, and the sample standard deviation is 10. Sample standard deviation, that is S, is 10. We have to construct a 96% confidence interval for the population mean. So this one is the problem on confidence interval. So in order to construct the confidence interval, basically what we do is we start with a line. It's basically the number line. Okay, and in the middle, we'll have the point estimate. That is the first thing we want to find. So the point estimate is the sample average in this case, which is 108. Now, in order to find the 96% confidence interval, we have to find the lower boundary for the interval and upper boundary for the interval. Lower boundary for the confidence interval is X bar minus margin of error, and upper boundary is X bar plus the margin of error. But we have to be very careful here when we determine this margin of error. And you can clearly see that the population is normally distributed, but the population standard deviation is not given. If the population standard deviation is not given, we know the formula for margin of error. We know margin of error is equal to T critical multiplied to S over the square root of n. Okay, it is margin of error is equal to T critical multiplied to S over n. Because the sample standard deviation is given, not the population standard deviation, the sampling distribution of sample will follow the T distribution. So we are going to sketch that T distribution to find that critical value. So say, for example, this is my T distribution. That's I have T values along the x-axis. And because this is the T distribution, we need the degrees of freedom. And here the degrees of freedom, as you can see, the sample size is 25. So the degrees of freedom must be 24. Also, we want to construct 96% confidence interval. So the area that goes in the middle should be 96%. So we can show that 96% area in the middle like that. So let's say that area. So this area that goes in the middle is the 96% area, 0.96. Now the remaining 4% area is divided on two tails. That means on each tail you have the 2% area, 0.02 here, and this one is 0.02. And the value that goes here along the x-axis, where I'm showing by the dot, is our T critical. Okay, that is T critical. Let's find T critical. So in order to find T critical using TI-84 calculator, we use T critical is equal to inverse T, area to the left of T critical. You can see area to the right is 2%. That means area to the left must be 98%. In other words, area to the left is equal to this area in the middle plus 2%. So 96% plus 2% is 98%, which we write as 0.98. And the degrees of freedom, we have 24. And if we type this in our calculator, we should get 2.1715. Okay, 2.1715. That is the critical value. And we were calculating this critical value to determine the margin of error here. So we are going to plug in that into this equation. So this is equal to 2.1715 times the sample standard deviation 10 over square root of 25. And if we simplify this, we should get 4.343. So the margin of error is 4.343. If we look at the diagram that we have drawn here for the confidence interval, we have the value in the middle. To get the lower boundary, we have to subtract the margin of error from there, from the point estimate. To get the upper boundary, we have to add the margin of error. So that's our next step. So lower boundary for confidence interval is the point estimate 108 minus 4.343. And if we subtract this, we get 103.657. So this is 103.657. Similarly, let's find this upper boundary here. So upper boundary for confidence interval is the point estimate in the middle plus the margin of error. That is 108 plus 4.343, which is equal to 112.343. So the upper boundary is 112.343. So with this, we are able to determine the confidence interval there. We are asked to write that 96% confidence interval. Now we can write it down here. Hence 96% confidence interval for population mean. For population mean is from 103.657 up to 112.343. So this is how we can find the confidence interval for the population proportion. Remember, in this example, population standard deviation was not given, so we use the t distribution. If the population standard deviation was given, then it would be standard normal distribution. Okay, we have one more example remaining for this video. So let's go to the last example. Here is my last example. Let's read through the problem and then try to solve this one. Okay. According to creditcard.com, 29% of the adults do not own a credit card. In a random sample of 500 adults, what is the probability that more than 30% do not own a credit card? Okay, so here in this problem, they have given the information about the general population here. Okay, if we look at the general population, 29% of the adults do not own credit card. Remember, this is the information about the adult only. So here, the population proportion is 0.29. Okay, P is equal to 0.29. That means Q is equal to, if 29% do not own credit card, remaining 71% own the credit card. So that will be, Q will be 0.71. So that is the information about the population. 29% of the adult, they don't own the credit card, whereas 71% they own the credit card. Now, in a random sample of 500 adults, now we are looking at a random sample of 500 adults, n equal to 500. We have to find what is the probability that more than 30% do not own credit card. We have to find the probability that more than 30% do not own credit card. We want probability that the proportion in the sample of 500, so P hat is greater than 30% or 0.30 is equal to how much? You can see there is the information about the population. We have the sample size. What we can do is we can quickly check how much is n times p and n times q here. So if I want to find n times p, that is 500 times 0.29, and that is equal to 145, which is greater than 10. Similarly, n times q is equal to 500 times 0.71, and that is equal to 355. This is also greater than 10. Since both these values, n times p and n times q, is greater than 10, it follows the central limit theorem. So we can say since n times p is greater than 10 and n times q is greater than 10, by central limit theorem, the sampling distribution of proportions is normal. Okay, by central limit theorem, the sampling distribution of the proportion is normal because n times p is greater than 10 and n times q is greater than 10. So we can say that the sampling distribution of the proportion is normal. And for that normally distributed samples, the mean of the proportion, we can write mu sub p hat is equal to p. Okay, mean of that normally distributed proportions will be equal to p, which is 0.29. Okay, and the standard deviation sigma sub p hat is equal to square root of pq over n, which is equal to square root of p is 0.29, q is 0.71, divided by sample size is 500. And if we do this math, this is equal to 0.0203. So what we know so far is the sampling distribution of the proportion is normal. Okay, sampling distribution of the proportion is normal. That's what we know from the central limit theorem. And for that distribution, we also know the mean and the standard deviation. So that is very important thing that we got from the central limit theorem. Mean is 0.29, standard deviation is this one. So because we know the distribution is normal, we can quickly draw that normal distribution. Let's draw that. Okay. Suppose this is my normally distributed or normal distribution of the proportion, I should say. So we have the proportions p hat along the x-axis. This is the normal distribution where the mean is mu sub p hat, standard deviation is sigma sub p hat. In the middle, we have the mean, which is 0.29. Now the question is, we have to find the probability that more than 30% do not own a credit card. So 30% or 0.30 will be on this side because here you have 0.29. So we can label that 0.30 is there. And we want the probability that it's greater than that. That means we can say this here to represent. So this probability is equal to the area shown here. So let's use our calculator to find that area. Now, probability that the proportion is greater than 0.30, because we are calculating the probability, we use the normal CDF. And then the lower boundary for the area is 0.30. Upper boundary is infinity. We go all the way up to infinity. Mean is 0.29, which is here in the middle, or which we have shown here. And the standard deviation is calculated here, 0.0203. 0.0203. And if we type this in our calculator, we should get 0.3111. So the probability that the average, on average, more than 30% do not own the credit card is 0.3111. So it's like 31.11% of the adult do not own the credit card. Okay, so if you want to calculate that percentage over there. Okay, so that is the last example for this video. I hope you find this video helpful. Make sure you practice questions like this and prepare yourself for your second quiz. Thank you so much for watching.